Good morning, one and all. So myself, S.A.ENGINEERING, working as Associate Professor in S.A. Engineering College. And about S.A. Engineering College, as you know that it was 28 years of excellence, and recently we received the Institute Level Research Center as a one credit for the S.A. Engineering College. And since we have autonomous for the past 10 years. And with this introduction, let me have a session today. And today I am going to tell you about algorithms, which was a very important topic in GATE that was prepared for 2 or 3% for the questionnaires that comes from the algorithms. And particularly I am taking the concept of divide and conquer, which we have a data structure concept, and mainly they focus on algorithm concept to explain how the reachability to have these kind of problems into a questionnaire session in GATE, through GATE. So through this video we can get a broad knowledge about attending these kind of questions that comes from the divide and conquer technology. Now let me introduce about the divide and conquer methodology. Divide is, as you know, that it's a methodology that adapt with dividing the problems into a sub-problems. So once you are encasting with a problem, it can be divided into a sub-problems, and again conquer. This is the main logic that adapt those sub-problems to done through the recursive process. So here we had a knowledge of dividing them into a sub-problem, and recursively we attempt the same problems into a solution. Then we gathered that, which means to be a combinations of the dividing sub-problems. Then we gathered that into a combined process. So altogether these three processes had a opportunity to give a better solution when comparable to the previous one. That's why we are embedding with the divide and conquer method in data structure, and here they mainly focus on divide and conquer through the algorithm concept. Next, I have taken 5 examples for explaining you the real-time scenarios that followed through the divide and conquer method. Say for first one, I am taking a merge sort, and secondly, I am going to tell you about binary search and Fibonacci series, then matrix multiplication, and then Strassen multiplication that invoked through the divide and conquer method. So algorithms generally focus on how we concentrate those methodology with the problematic solutions, and GATE also concentrate on giving such questions as 2 or 3 questions we can expect from the divide and conquer, and I am just going to tell you how we can implement these things. So first of all, I am going to take you about merge sort. So as you know that merge sort mainly concentrate on the divide and conquer method, and this divide makes your entire problem into a subcategory, and the numbers are now having a subdivisions, and then finally it combines that sorting in a different way. So while taking a bubble sort or other type of sorts, they invoke with a logarithmic n, where each sorting will take more number of repetitions, and again repetitions will occur, redundancy occurs, and that's why we have a large number of time complexity and space complexity. So that's why the successful implementation of merge sort taking into a grant of using divide and conquer method. So because of using this divide and conquer method, the merge sort plays a vital role in making a sorting with a very efficient way. So first of all, divide. So it takes us entire solution, entire sorting numbers into a trivial nature, and then again the conquer method will do the process into a recursive nature with the 2 sub-arrays. So when taking these 2 sub-arrays, again the solutions from each array will now gather, and it was combined in the large time range. So this scenario is completely continuously followed for repeated time based on your n number of inputs. That's why merge sort plays an important role in sorting technology. And here now the entire time complexity and space complexity will design with the algorithm. We had a t of n equal to 2 to the t to the power n by 2 plus asymptotic negation n. So when dividing and combining the scenario, we had a 2 times of t n by 2. So that is the entire n number of set is now divided into a sub-problem, and again that will be twice it will done, and the recursive nature will given here. So entirely the sub-problems is now gathered, and now the resultant will be the solutions for the merge sort. And here when I am taking the next level sorting, if we are using that in the sorting, then definitely it will be highly qualified for the searching techniques also. And here I am taking the second example as binary search. So as you know that binary search has a entire thing to be divided into a two sub-arrays, two sub-elements, and again it will make a searching in the two content. So here when arrays are happenings and the single array is now divided into a multiple array, then again the divide and conquer method is getting invoked. So as you know that merge sort is a efficient sorting technique. Similarly, the searching in searching techniques, the binary search will play an important role while it is following the divide and conquer method. And now divide takes up the role of taking the middle element, and conquer making it recursively for the searching of one time scenario. And third, it has the combination of a trivial mostly it is invoked through the algorithm. So as you have a description like this sub array, once it search, it find out the element, then definitely there will be the successor rate, and it was very great in algorithm implementation while we following the binary search. Let me go with an example. So here I had a list of 3, 5, 7, 8, 9, 12, 15. So it is comprising of 7 elements, and in this term we need to find out the element of 9 through the binary search with the divide and conquer methodology. And now when I am having the divide and conquer method, the binary search will separate the array with the middle element. That was the first technique that followed in the binary search. And first of all, from this given thing, from the 7 elements, we noticed that 8 is the middle element, and now the searching will divide it into a two sub arrays. First it will check whether 9 is equivalent or greater or lesser than 8. So as per the list, 8 is the middle element and 9 is having a higher than 8 and it is not lesser than 8. So here the searching is now directly enters into the second list. So now the searching will become very less computational redundancy, and now instead of going to the full list, the searching will now get into the second sub list, which was with the 3 elements. So in the first case, when I am giving the sub array, again it takes up the middle element, and now it searches for among the 3, the middle element is as 12. So with this searching, again the 9 is comparing with the middle element. So now when 9 compared with 12, it was greater than 9, then 9 will left out with the left sub array. So again the next point, it goes to directly it goes to the 9, which was the easiest way to find out the searching element from the n number of lists. So this is the major successful implementation for the subarrays with the merge sort and then binary search. Again, if you are noting this, 9 is found with the very simplest step of 3 to 4 thing, which we have a 7 elements. If in case of n number of elements, even though it has a n number, again it was very easiest thing to implement through the divide and conquer methodology. That's why the T of n, when you are calculating the time complexity, the T of n will gives you 1 into T of n by 2 plus the notation sigma complexity. So when we are making the recursive factor, again it is having only multiplication of 1 with the subarrays of n by 2. So when I am having more, even though I am having more number of elements, my complexity level of time is reduced with 1 into T of n by 2 plus the sigma n. So here the dividing and working nature of binary search is entirely depends on the conquer method. Next, we have cases. So first, if I am having the case of n to be a 0, so if I am reducing the element into a 0, then the n to the power 0 is 1. So my search will concentrate on one time scenario. And now the case 2, we have a k as a 0. That is the entire list of content is making with a, that is division with a 0. Then again we have T of n equal to log of n. So simpler, getting into a simpler way, the binary search is entirely dependent on the divide and conquer, which gives you a very simplest method of finding the searching element. Next, we go with the third example as Fibonacci series. Here we have a recursive definition. First of all, the Fibonacci, as you know, that it was highly dependent on the recursive method. Here f of n equal to 0, and if n equal to 0, and f of n equal to 1 if it is 1, n is 1. Then after that, if next element exists, then 0, 1, then the combination of 0 plus 1 plus the nth element. This will be the continuation for the recursive nature of Fibonacci series. So this is what here explained, and here with this definition, f of n minus 1 plus f of n minus 2 if n greater than or equal to 2. So here this predict the elements with the following nature if we are giving the n. So as I mentioned here, 0, 1 plus 1, then we have a continuous series with the formula applied. So this is the nature of Fibonacci series. But in terms of recursive, again, when you have a n numbers, then again it has a difficulty in finding those n numbers when it attempts for more recursive function. So here the divide and conquer will massively occur with a naive recursive algorithm. So simply go with the recursive, again we have a naive recursive algorithm where we can have an exponential time of making those squares of these recursive function. Say here, when it equivalent to root 1 plus root of 5 by 2, again I am taking the subproblems and the ratio will be reduced when I am making that into a dividing nature. So that's why they are implementing here with the along with the recursive, we are making the divide and conquer also. And now this is the multiplication nature. So from the Fibonacci, the third one, then we go for the next example that was done through the matrix multiplication. So when I am having these kind of scenarios with a 3 by 3 matrix or n by n to n matrix, we have a multiplication thing, but it will need to have a row and column wise multiplication that requires more number of attempts and more number of recursive process. So here I am going with an example. So here when we have a multiplication process, first of all we taken the row wise size and then column wise size, then we are computing that with a temporary variable k, then the computing Cij is now equivalent to Cij plus Aik dot Bkj. So when have a n into n rows and columns, we have to invoke all these things for n number of times. So again we have a nature of making more time complexity and space complexity, so which needs a very short duration for the level of n into n number of cross multiplication. So here, instead of going into these kind of for looping and conditional statements, it is very far better to have a divide and conquer method to attain this process. Say for example, here in this process we have a running time of sigma of n to the power cube. So if I am giving 3, then 3 to the power cube, it's a 27. So 27 times we need to have a multiplication with those recursive function. So this creates more number of space and time complexity. That's why the entire thing will be now invoking through the divide and conquer method, and this divide and conquer method will taken like an example of 2 by 2 matrix. Here I am given the variables notations R, S, T, U, which was our resultant matrix, then A, B, C, D, these are the row and column wise. Now I want to have a solutions for C equal to A dot B. Here I am as a major basic thing, the multiplication will invokes for these many types, that is AE plus BG, then AF plus BH, CE plus DG, CF plus DH. So the row and column, similarly row and columns, like that we need to do with that for 4 times for the RSTU values. And here after invoking that, we are getting the solutions for 8 multiplication of submatrices and 4 addition for submatrices. So this is the total invoking calculations for matrix multiplication. And here if I am doing that with recursive nature, again we can have solutions for reducing that also. Say here I am taking 8 multiplication. So 8 multiplication will create a more time complexity which cannot be invoked for n number of times. So here I am just bringing out the divide and conquer methodology. So here first I am with the divide and conquer, we have a 8 into t to the power n by 2 with the n square. So when working additional submatrices, again we are, whenever we are adding, again it is done for the recursive time and it has a difficulty of doing the time complexity. So again we are making that changes with the process of not in the ordinary way. We are doing that with a divide and conquer, and here I am just have a 2 by 2 matrix with only 7 recursive matrices. This is possible when we are implementing the divide and conquer method. Here I am just giving you the 7 recursive submatrices and multiplication that done for the matrix multiplication, and this process is introduced by Strassen. That's why it called Strassen's matrix multiplication. And here just I am giving that 7 formulas into a P1 to P7, and we here I am just giving you the variables with the definitions of variables with the A dot F minus H, P2 is equal to A plus B dot H, P3 C plus D dot E, and P4 D dot G minus E, P5 A plus D dot E plus H, P6 B minus D dot G plus H, P7 A minus C dot E plus F. So here these 7 calculations will done with the 7 multiplication. And here I am showing you the entire calculations for RSTU. So here with this calculation, this P1 to P7, how they are working in calculating this RSTU, this should be noted down, because you can expect a gate questionnaires from Strassen multiplication, and if you are expecting those questions, you can have a knowledge of these P1 to P7, and straight away you can calculate this RSTU with the simplest form of getting this instead of using the ordinary matrix multiplication. And now RSTU, here we just invoking this P5, then P5 plus P4 minus P2 plus P6, this will resultant in the R value, then S value P1 plus P2, T P3 plus P4, then U is equal to P5 plus P1 minus P3 minus P7. So this formula, when we are deriving this, we can easily adopt with the RSTU value. And by invoking this, we had a resultant of 7 multiplication and 18 addition. So instead of going to the arithmetic operation, when we are doing 7 multiplication and 7 to 8 addition, that will reduce your time complexity instead of going to a normal matrix multiplication. And now we have no any other commutative nature in this, and that's why we have the example of deriving this R value. So while I in calculating R, we had such a implementation, and finally this will derive with the AE plus BG, which we done for the normal multiplication. So this was reducing to the simplest form, and whenever you want to have a 3 by 3 matrix or n into n matrix, say for example 50 into 50 matrix if you are doing, then easily you can cover up with this 7 nature. That formula will enough to have your Strassen's matrix multiplication solution. That's why we are using the divide and conquer method. And here, by using this divide and conquer method, the partition, each partition will hold the take up a recursive nature, and first the dividing partition A and B will gives you n by 2 and n by 2 matrix, and again the forms will be multiplied by plus and minus. So this is the first step that invoke for the dividing technology methodology. Then conquer will give you 7 multiplication with that n by 2 and n by 2 matrix, and combination will give you C, which has the plus and minus. Again we have a plus and minus. So instead of going to the multiplication, we are mostly dependent on the plus and minus with the Strassen multiplication. And here, after invoking this, we got a very little bit solutions of T of n equal to 7 of T n by 2 plus the n square. So when you have the time complexity, it gradually reduces because of using the plus and minus instead of multiplication. And here we can expect the questions in this form of taking knowledge about divide and conquer algorithms, and then even with the examples of binary search, match sort, Strassen multiplication, and even several sorting technology, heap sort, everything will be combined with the divide and conquer methodology. So here I am going to tell you about a glimpse of a gate expected question, and that's why I am gathered here for the previous year sample question. So they can give a question that is like, they give the sorting technology. As I mentioned that they can take questions from the sorting also. So here they just mention about the technology used here, but they are asking you about which methodology is not invoking with the divide and conquer. So as you had a knowledge about sorting technology, you can easily attempt this question, because when we have these things, equivalent algorithm highly depends on divide and conquer, and then Cooley-Turkey, fast Fourier transform, then quick sort, all these things are getting into a divide and conquer. Through through that only we are getting a very simplest time complexity, and that's why the answer for this question is heap sort. Heap sort continuously have the heaping concept, not with the divide and conquer methodology. So heap will takes up the individual transformation of heaps and not with the divide and conquer. So as you understand the sorting technology, you can easily attempt this question. And the second sample question you can expect is, here they will give the entire quadratic equation with the solutions of finding the minimum number of set of attempt. So here they given the 3/3 quadratic equation, and they are expecting you to give the solutions for input. So when I am getting this as a multiplication, now they are asking for the recursive nature with how many times it can be implemented. So here straight away they given the quadratic equation like P of x equal to a of 0 plus a1x plus a2x to the whole power. So here I am taking the consideration of this equation, and now the answer is 3. Because the explanation, I mentioned this explanation through this video, that P of x we can convert that into a P of a0 equal to a0 plus, we are taking the variable x outside, and a1 plus again we are taking x. So now it becomes a calculations of 3 times, 1, 2 and again 3. So here minimum number of calculations we are undertaking using the divide and conquer is 3 times. So the answer is 3. The third question we can expect is the worst case. They ask you to find out the worst case scenarios. So worst case scenarios, here they give an example of min-max algorithm. So you know that from the entire tree, min-max will find out the strategy with the alternate solutions of minimum and maximum. So when we go through these things, when I have a high concentrate on min-max algorithm, here they given that array with the min-max of A2 comparison. So A1 they give min-max, and for A2 it has a min-max comparison by scanning the array linearly. So here it was without divide and conquer, and A2 is with the divide and conquer. Now they are asking for the question whether the unsorted array is now given as an input, how long the A1 and A2 will take for the sorted array, whether A1 is better or A2 is better. Now we had a chance of getting the worst case scenario. So they given the idea about A1 and A2, and now they are asking us to give the comparison of A1 and A2 in terms of worst case scenario. As for concern, as you know that when we are implementing divide and conquer, the A2 will takes up the time complexity in a very lesser way while compared to the A1. So here obviously the answer will be A1, which is greater than A2, and I am giving the explanation how it takes the time complexity. So when we are comparing the divide and conquer method, this is what the first logic A1 will invoke by 2 to the times of t n by 2 plus 2. This is what the minimum level that occurs to the given array, and here with the conditions of linear search with the divide and conquer, we are getting t of n equal to 1.5n minus 2, which was very simpler way and taking up very less time complexity. So this is solutions you have to find out. So in this kind of comparison, they always give you the algorithms and they ask you to find out this time complexity for the sorting technique, searching or matrix multiplication. These are the expected questions in the algorithms level of GATE entrance examinations. And with that, I just conclude you that divide and conquer method is the best solutions for finding the best nature of sorting and searching and other multiplication nature in the data structure. And here the sub problems, even though they are sub problems, again the sub problem solution is now combined and give you the better solution. So the logarithmic implementation also I have explained, and you may have a better idea to have a divide and conquer method, and have a practice in it, find out the solutions for the algorithmic question, and let you have a good knowledge about the algorithms. And my best wishes to attend this algorithm chapter for the GATE entrance examination. Thank you, and we will meet you in the next slot. Thank you.